Hey guys, in this video I want to go ahead and talk to you about another rate accumulated problem. I'm pretty sure you're going to get a problem like this, and so it's very important just to kind of get in the habit of doing these. So this is from 2016, and it says water is being pumped into a tank at a rate modeled by W of T, okay, in liters per hour. Okay, notice the word rate, okay, and it's going into a tank, okay, between 0 and 8 hours. And then it says water is being removed from the tank at a rate modeled by R of T in liters per hour. Okay. And it says R is differentiable and decreasing. Okay. Between 0 and 8. Great. Selected values of R of T are shown in the table above. Okay. And it says, so this is the table. So we have two things here. This is the rate going in. This is the rate going out. And then it says at time t equals 0, the initial condition in the beginning, we have 50,000 liters of water in the tank. The first thing it says, estimate r prime of 2. Well, what's prime? Prime is the derivative, the slope, the rate of change. Well, where's 2? 2 is not here, but 2 is between 1 and 3. So what do? You're going to use these guys here that are between, okay? 2 is between 1 and 3. You're going to use these guys to figure out your slope, your rate of change. So what you do, guys, is f of b minus f of a over b minus a. Okay? And then you should get 950 minus 1190, f of b minus f of a over 3 minus 1. Okay? And then if you notice, you're going to get negative 120 liters per hour squared. Now, if you ever forget the units, okay, think about this. What's this value here? Well, that's up here, liters per hour. And then what is it down here? This is just hours, so it's liters per hour per hour. So it's telling us that at t equals 2, at 2 hours, okay, the rate, okay, of water leaking out is decreasing at 120 liters per hour. Okay, so that's the reason why it's negative. All right, guys. Now the last thing I want to make sure that you guys do is make sure you put the units. Okay. It says indicate the units of measure. If they don't ask for it, you don't give it. But they always ask for units of measure. If you don't give this, they're going to take away a point. Very important. The second part, it says use a left-hand Riemann sum with 4 subintervals indicated by the table. Okay, so I'm going to stop there. What are 4 intervals? Okay, I'm going to go here. 1, 2, 3, 4. 4 rectangles. They're going to use the left hand, so we're going to make a dot on the left hand corner. Okay, and then it says to estimate the total amount. That's a key word, total amount. This is a rate. When you integrate a rate, okay guys, when you integrate a rate, you end up with an amount. Okay, so they want the total amount of water removed. So what are we talking about? We're talking about the table still. Okay, the water removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? So what do they want? They want the integral from 0 to 8. Okay, of what? What's the R of T? Because that's coming out. But we have to use a Riemann sum. So remember, this is a rectangle. Okay, so how do you use it? What's the area of a rectangle? Base times height. What's your base? From 0 to 1, what's that distance? 1. What's the perpendicular height? We're using the corner. This is my y value, so 1 times 1340. Okay, so 1 times 1340, and that's my rectangle. Plus, now I do the next rectangle. Okay, the distance from 1 to 3 is 2. 2 times what? Boom, this guy, 1190. All right, 1190. Plus, do the next rectangle. From 3 to 6, that's 3 times what? 950. Okay, and then the last one from 6 to 8 is 2 units, and then what am I using? 740. Okay, 2 times 740. And if you do that correctly, you should get 8,050 liters. And this, I'll just make this in equals. Okay, it's because we say it's approximately, and then it equals 8,050 liters. Okay, makes sense? Cool. Now what does it say? Is this an overestimate or an underestimate of the total amount of water being removed? Well, is this function increasing or decreasing? And you notice, look at 1, 3, 6, 8. What we start off with 1340, and then it goes what? Lower and lower and lower and lower. So this guy, think about it like this, is doing this. Okay, if I make rectangles, and they're left hand, that means the left corner is touching. Okay, the left corner is touching that graph. That means this guy's going to be an this is an overestimate. Okay, because the graph is going to be under the rectangles. Okay, so you would write this is an overestimate since r is a decreasing function. Okay, this is an overestimate. Okay, since r of t is decreasing. Okay, is decreasing. And that's it, guys. All right. All right, let's see if we can do part C. It says use your answer from part B to find an estimate of the total amount. You see that again? Total amount of water in the tank to the nearest liter at the end of 8 hours. So you want the total amount of water removed, okay? The total. Now you got to think about what's going on here, okay? Water's being pumped in, okay? Now think about what's going on here. So part C. To get the total, what's going on? What do I need? Well, you need, well, what did you start with? Okay, your initial. What did you start with? Plus what's going in, okay, minus what's going out. Does that make sense? Because that's how you're going to get the total. Okay, what do we start with? Okay, what's going in and what's going out. That's your accumulated rate, period. So when we're talking about the total in this case, okay, and you can write total on the exam too, okay, because it says use your answer in part B to estimate the total amount of water in the tank. All right, so what do we start with? It tells us that we're starting with 50,000 liters. Great, 50,000 plus what's going in? Well, water is being pumped in using this guy. Okay, so we're going to go the integral from 0 to what? 8. Okay, of what? WT dt. Great. That's what's going to determine how much is going in. Minus, okay, minus what is going out. Okay, now what is going out? Okay, what's going out? Well, the integral, and I'll do it this way. It's an extra step, but it's okay. Minus what's going out of RT dt. Does that make sense? This is what we started with. This is what's going in, and we subtract what's going out. Period. But we already got this, didn't we? Right? Didn't we get this in part B? It's 850 or 8050. So essentially, you don't really need to write this. You can just put 8050 here. Okay, so approximately 50,000 plus the integral from 0 to 8 of WT dt minus 8050. Okay, now remember, you can use a calculator, and you should, just to double check, and if you do it correctly, you should get 49,786 liters. Okay, don't forget those units. Okay, guys, that's it. Not that hard. That would give you 7 points if you did all parts A, B, and C. So if you see it, it's not too complicated if you understand what the problem is telling you. Okay, let's go ahead and do the last part, guys. Part D. Okay, for the time interval between 0 and 8, there's a time. Is there a time t when the rate at which the water is pumped into the tank, okay, the rate of the water pumped into the tank is the same, that means equal, to the rate at which the water is removed from the tank? Now, yes, part D's are always going to be the tougher ones, but think about it. We're visual, okay? The rate at which the water is pumped into the tank is going to be the same as the water removed from the tank. Now think about this. Now we're talking about between 0 and 8, okay? So let me draw a picture here. Now at the rate that's going inside, okay, this is the rate that's going inside. When t equals 0, I get 0 squared, 0 divided by 20 is 0, e to the 0 is 1, so I end up with 2,000. Cool. So At 0, I end up with, let's say that's 20,000 right there. Okay, so we end up W0 is 20,000. Okay, actually, sorry, 2,000. It's only 2,000. Okay, all right. Now, what about W of 8? When you plug in 8 here, okay, W of 8, okay, is going to be, I think it's 851 point something. So let's say 8 hours over here, it's 8, yeah, let's say it's over here. All right, now these functions are continuous, of course. So it does that, okay? Great, so that's just the water going in, okay guys? That's just the water going in. Now, what about the water going out? Okay, what do we start with? 1340, okay, great. So 1,340, that's 2,000, maybe right over here. Okay, that's 1340. So R of 0 is 1340, okay? That's the rate going out, okay? Now, where does it end up with? It ends up at 800 on the 8th hour. So let's see. Let's see here. So this is 851. 700 would be right underneath here. Okay. Now, you see here, I have to go from 1340 to 851. Okay. And I have to go from 2000. I have to go from 1340 to 700. Okay. Is it going to pass the 851? Absolutely. Does that make sense, guys? So this guy start off at 1340, right? Is decreasing. Now, am I going to cross 851? Yes, I am. Whoops, that's R. Okay, because I need to get to 700. If you think about it, it's going down. I passed 800, right? 1340, 1300, 1000, 800, 700 to get to here. So I have to pass 800. I have to pass 851 to get to here. So there is at least one time where it's going to cross. And what you would say is, because of the intermediate value theorem, okay, there's at least one point where W of t equals R of t. Now remember, these are human beings and they want to give you the points. If you draw this out, that should be sufficient because you're demonstrating the intermediate value theorem. Okay, and you label your points. Okay, and they know IVT, intermediate value theorem. These are calculus teachers. Okay, where WT equals R of t. And if you demonstrate this, of course, much more neater, you should be able to get the points. All right, guys? And I did it visually because we're more visual, and that's how one of the first ways we learn. Okay, because part D is a little bit more abstract. So hopefully that helps, guys. Let's go ahead and do one more question. This is from 2017, and this is question number 2. And you notice, like, almost every year you get that related rate question. Sorry, not related rate, rate accumulation. All right. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Okay, picture it in your mind. Customers remove bananas at this rate. Okay, makes sense, right? This is going out. And then F of t is measured in pounds per hour. T is the number of hours after the store opened. After the store has been open for 3 hours, that's important, the store employees add, you see that? They add bananas to the display table at a rate modeled by this guy. So this is going out. This is going in, okay? Where G of t is measured in pounds per hour and t is measured is the number of hours after the store opened. Okay, remember the first question is the easiest. A and B usually are the easiest. How many pounds? You see that? How many pounds? Remember, what are they giving you? They gave you a rate. How many pounds of bananas are what? Removed. Removed from the display during the first, 2 hours. Integrate a rate. So we're going to integrate from 0 to 2 of what? What's being removed. Which function is telling me that stuff is being removed? The first one. So all you have to do is write the integral of from 0 to 2 of f of t dt. And use your calculator. You don't need to put in the whole function, okay? You don't need to put in this whole thing here. Why? Because they tell you that f of t equals this. So if you just put this on your paper, you're perfectly fine. And, whoops, that's going to equal, let's see, you put in on your calculator, you get 20.0, whoops, 51175. Now you want to either round 4 decimal places or round 3 decimal places or truncate. So you want to either leave it like that or round. But I would just leave it like this, 4 decimal places. Just don't even touch it. All right, guys? All right. So we got the answer. Okay. How many bananas? Okay. But wait a minute. We have to put our what? Our units. So you would say 20 pounds of bananas. I'll just say it. 20 pounds of bananas are what? Removed from the display table during the first 2 hours. It's very important, guys, that you understand what the math is telling you, what it means, not just to do it, okay? Because it'll make everything else easier. So we found out that 20 pounds of bananas are being removed after the first 2 hours, okay? Part B, find f prime of 7, period. Okay, well, wait a minute. What's f prime of 7? You got to take the derivative of the f function. This guy. Okay, that's what you got to do. Take your calculator, all right, your TI or whatever you're using. Plug this in. Okay, you're going to get negative 8.120. Okay, and it says using correct units, explain the meaning of f prime of 7 in the context of the problem. So what had just happened? This is a rate. The rate of removing bananas. You just took the derivative of a rate. So now you get a rate of a rate. Okay? So what does this mean? After 7 hours, after the store is open 7 hours, the rate, okay, the rate at which bananas are being what? Removed, removed is decreasing by 8.120. Okay, so I'll say it again because I don't want to write it just for sake of time, guys. But the rate, okay, or after the store's open 7 hours, okay, the rate, okay, because that's what that means, the rate at which bananas are removed from the display table, okay, is decreasing by 8.120 what? Pounds per hour per hour. Okay? I know it sounds kind of weird, but that's the correct answer because you take a rate of a rate. So at t equals 7, after 7 hours, you are removing, okay? Okay? It's decreasing, okay? At 8.12 pounds of bananas per hour, okay? So hopefully, guys, that didn't confuse you too much. All right, part C. Is the number of bananas on display increasing or decreasing at t equals 5? Interesting question. Increasing or decreasing? Well, what are we talking about? Okay, we're talking about rate. Okay, well, let me see here. Increasing or decreasing? So you have, okay, you have a table, you have 50 pounds. Okay, this is being removed, this is adding. So you're trying to think, okay, after 5 hours, are more bananas being put in then are taken out, or is it the opposite way around? Okay, well, let's just go ahead and do the math then. That means that I want to find out what is f of 5. Okay, what is f of 5? And you know what? I should have done it on my calculator, but I didn't. Okay, and then you also figure out what g of 5 is. Okay, and I'm sorry guys, I forgot to do that one. But what happens is when you take, okay, g of 5 and you subtract f of 5, you get negative 2.26. Okay, you get negative 2.26. All right, think about it. What's g of 5? The number of going in. What's f of 5? Okay, the number of bananas being taken out. Okay, so because g of 5 minus f of 5, it's less than 0. Okay, what's happening? The number of bananas on the display table is what? Decreasing. Does that make sense? Decreasing. So what happens? They're taking more bananas than they can restock them. Okay, the number of pounds of bananas on the display table is decreasing. Okay, so hopefully that makes sense. You have two rates that you're talking about here. Okay, that one's a bit of a tricky one. It can be. You just have to kind of read it carefully. And the last one, letter D, how many pounds of bananas are on the display table at t equals 8? Now this is your classic one that you're always going to get. How many pounds of bananas are on the display table? This is the total, just like we did on the other problem. So they want us to find what's a total. So remember, what's a total? Well, think about it. Okay, what did you start with? Your initial plus what's going in minus what's going out. Okay, so if you want to figure out the total, what do we start with? Well, it tells us we started with 50 pounds of bananas. Okay, started with 50 pounds of bananas, so we're right here. Okay, plus what's going in? Okay, well, this guy's going in. Okay, this guy's going in. So we're going to take the integral, okay, of g of t dt. Now you got to be careful here. Is it from 0 to 8? No, it's not. It says after the store has been open for what? 3 hours. See, it's not from the beginning. It's from 3 hours. Okay, so it's from 3 hours, okay, to the 8 hours. Okay, minus now what's being taken out. Okay, the integral from 0 to 8, because that's from the beginning, of f of t dt. Okay, so you have those two integrals, but hopefully it makes sense because what you start with, what's going in, what's going out. Boom. Okay, so you do that, you plug it in your calculator, you should get 23.347 pounds of bananas. Okay, and I would say total pounds of bananas are displayed on the table at t equals 8. Okay, you notice how I had to use the time there. But hopefully guys, these problems are getting easier, and I'll continue to upload some more because the most important thing is that you understand what the math is telling you. Alright guys, send me questions if you need me to do any problems, and then I'll talk to you guys next time.